All right, I think it's time, so let's begin. My name is Maciej Sławik. I'm a tech leader at Lizard Media. I'm also a Magento trainer at Nobleproc. I want to talk to you today about full-page cache and hole punching at the rookie path. We will start by talking about what full-page cache is. I will tell you a bit more about Varnish, what Varnish is and how to configure it in Magento. Then we will talk about hole punching in Magento, so how to make Magento stop caching some stuff. And we will talk about customer sections, and I will show you an example. Full-page cache. Full-page cache means storing the entire web pages in the cache of the application. That is, saving the entire HTML output of the request in the cache storage. This gives you an increase in server response speed because the FPM doesn't have to render the entire response on each request. And this means that you get a reduction of application server load and also a reduction of the DB server load because you get less requests to the database. In Magento, there are two types of storing full-page cache. You can use the built-in cache storage. That is, you can store the full-page cache in files, in Redis or the database. Or you can use an external cache storage, that is Varnish. The difference is that when you use an external service like Varnish, all the requests that come to the server from the customer's browser, if they are stored in the external storage, they don't have to go all the way to the application server because they are returned to the customer directly from the external service. And when you use the built-in cache storage, the response has to go all the way to the FPM, and Magento, or at least some part of Magento, has to be bootstrapped to retrieve the cache response from files or from Redis. And by default, in Magento framework, all the web pages are stored, are cached in full-page cache, and each module, each controller has the responsibility to declare whether if a page should not be cached. That is, in a default Magento, pages, for example, customer account or the cart or checkout are not stored in the full-page cache because the modules declare them not to be cached in full-page cache. Varnish. Varnish was originally developed to be an HTTP accelerator, unlike some of its rivals. It uses virtual memory to store the full-page cache, which means that it's very, very fast because the write and reads to the virtual memory are very quick. And it relies on the operating system to determine if some parts of the virtual memory should be stored in the disk, in the hard drive. Varnish uses .vcl files for configuration, and it uses HTTP response headers to determine if the response from the application server should be cached or not. So the application server, when giving a response, has to send HTTP response headers, which will tell Varnish if a page will be cached or not. Also, Magento can act as a load balancer if you have more than one application server, that is more than one backend. Varnish can act as a load balancer and send the traffic between the backends. And it also can run health checks to determine the health of each of the backends. And if one of the backends comes unhealthy, that is, it doesn't respond, Varnish will automatically route the traffic only to the healthy backends. To enable the external full-page cache storage in Magento, you can do it in the administration panel of the site. You have to go to Advanced and System. You have to choose Varnish Cache, and then you have to fill three fields. The first field, access list, tells Varnish which hosts or IPs are allowed to purge the Varnish cache. Then, in the backend hosts, you have to put the IP addresses or hosts of the backends that Varnish will route the traffic to get the responses, and then you have to configure the port of the backend or backends. Then you have to save the form, and then you can simply generate a VCL file, VCL configuration file for Varnish using one of the buttons. And you simply have to add the generated VCL file to your Varnish installation. And in terms of configuring Varnish, that's all you have to do. There's also one more thing you have to do in Magento. You have to use the Magento executable to run the command you see on the screen, and you have to set the host or hosts where Varnish is installed, and this will tell Magento where it should send requests to purge Varnish cache when full page cache is being purged. What are the specifics of Varnish in Magento 2? By default, in Magento, only get and head requests are stored in the full page cache. So post requests are not stored in full page cache, and put requests aren't either. And the second part is that Magento uses the Magento Veri cookie as the second part of the caching key in Varnish. So when saving a web page in full page cache, the first part of the caching key is the URL of the page, and the second part is the Magento Veri cookie that is generated for each customer, and it's saved in customer's browser. And the cookie contains data such as is the customer logged in, the chosen currency, the chosen language, customer group. Magento also allows developers to add custom data to the cookie to add some extra information about the customer. The thing to remember is not to add information that are specific to a single customer, for example, like a customer ID, because it will cause Magento to generate a different Magento Veri cookie value for each customer, and will make Varnish cache the different responses for each customer, which will generate a lot of data, and it will lose its purpose. Now, how does Varnish fit into the Magento architecture? Unfortunately, Varnish doesn't support SSL. So if you want to use SSL, and you should, in production, you have to add an extra layer, an extra Nginx server before Varnish. The service is called an SSL termination proxy. So when a request comes to the application server from the browser, the request first has to go to the termination proxy. Then the SSL is the request is decoded, and it is sent directly to Varnish. Varnish determines whether it has the page stored in the full page cache or not. If it doesn't, the request goes to one of the backends, so it goes to the application server cluster. One of the backends generates the response with the response headers and sends it back to Varnish. Varnish, using the HTTP response headers from the response, determines whether the page should be saved or not. If it should, it's stored in full page cache of Varnish. If it shouldn't, it goes directly to the termination proxy, which encrypts the response and sends it back to the user. Now, what's hole punching? Hole punching means making a page not to be cacheable. Not to make a page not cacheable, there are two ways. You can either add a cacheable false flag to any block in the layout of the page, or you can manually set response headers in your controller to make the page not cacheable. If you decide to use the flag cacheable false on a block, it works that way. Magento, when it generates the page, it goes through all the blocks in the page. It checks each block if it has the flag cacheable false, and if it does, it sets the response headers to make the page not cacheable. It's important to remember that when you add cacheable false block to a page, it will automatically make it not cacheable. So if you add a block that has cacheable false to the default layout, it will stop the entire page from being cached in full page cache. How does Varnish determine if a page should be cached? In the first snippet, there are the response headers that are sent from the application server to tell Varnish that a page should be cached. The application server also tells Varnish when the page should expire and when the page should not be cached. The expires date is set to 1 year before. Now, something more important for a developer. How do we know if the page was served from Varnish or not? When you are more experienced developer and you know your website well, you can determine if the page was freshly generated or served from full page cache just by looking at the response times. But if not, when you are in Magento developer mode, you can check the response headers to find the Magento cache debug header, and if it was a hit, it means that the response was sent directly from Varnish, and if it was a miss, it means that the response was generated by the application server. When you are in a different mode than developer, you don't get those headers, but you do get the H header. The H header is the H of the page in seconds. So if the H header value is 0, it means that the page was freshly generated, and if the H header is larger than 0, it means that it was served from Varnish. In terms of performance, this is a screenshot from my developer environment. This was when Varnish was disabled. All the caches were enabled, and full page cache was enabled as well, but I was using the built-in full page cache. And the response time, the time to first byte, was around 300 milliseconds, which isn't bad. But when I enabled Varnish, the response time went down to 1 millisecond. The catch here is that I was doing the performance check on my local environment, which means there was no network lag. So that's why the response time was 1 millisecond, and in production environment it's not really realistic. But what you can expect is that when you don't use Varnish in your production environment, a good response time is probably around 200 milliseconds, and when you use Varnish, the response time should be around 50 or 60 milliseconds, which means that you should always get around at least 4 times performance increase when you use Varnish. Now let's introduce two concepts: public content and private content. Public content is the data that is not specific to a single user. It's stored on the server side. An example of public content might be a category page or a product page. And private content is the data that is specific to a single user, and it's stored in the browser. It can be information about the contents of the minicart, for example. If we use full page cache and all the web pages that are stored in full page cache are stored server side and are not generated for each customer individually, how do we add user specific data to the web pages? Because e-commerce is becoming more and more user focused, and it should be more and more personalized for each customer. So how do we do that? This is where customer sections library comes to play. Magento comes with a built-in library for handling private content for customers. It uses a JS library customer sections, which listens to HTTP requests. By listening to the HTTP request, it determines when some data stored in the browser should be invalidated and refreshed, and automatically sends requests to the backend to refresh the data that is stored in the browser. How do we do that? To create our own customer section, to add our own user-specific data, first we have to add our own implementation a class that will generate the data that will be sent to the front end using dependency injection.xml. In the custom name field, we have to place the name of our own customer section. Then in sections.xml, we have to add all the controller routes that will trigger our customer sections regeneration. So in this example, this is the example from the compare products module. The compare products section data should be invalidated on each request to add a product to compare, remove a product from compare, and clear the data. Then our class that will generate the data for the front end has to implement the interface section source interface. It has just one method that returns an array of data for the front end. Let's see it on an example. We have the mini cart. When we start browsing Magento, the mini cart is empty. When we decide to add a product to cart, we click Add to Cart. The request is sent using Ajax, and the page doesn't reload, but the contents of the mini cart are reloaded, and the product is added to cart. How does it happen? First, when we click Add to Cart button, the request from the top is sent to controller at checkout cart add. Controller to add the product to cart, and then a second request is sent. The second request is sent automatically by the customer sections.js library, and it says that two sections should be updated when the checkout cart to add request was made. Those are messages and cart sections. And the customer sections know that those two sections should be updated because in those two modules, those sections were added for this controller. This is the response for the sections update request. The response has two objects where the names of the objects correspond to the names of the sections, and the data in both of those objects were generated in the section source interface implementations. For the cart section, the request was made because the checkout cart add action was added for section cart in sections.xml. This is the implementation for the cart section data provider. As you can see, it returns an array of data. And the keys of this array correspond to the names of the properties for the card object in the response for customer sections update response. To use the data from customer sections that is stored in the browser, you have to use require.js to load the customer data library, and then using this library, you can simply use the get method to get the contents of the section by using the name of the section. And what it returns is a knockout observable, which will be updated every time the section data changes. This means that when the data changes, your custom front-end component will be updated as well. To sum up, the things I'd like you to remember is to avoid using cacheable false directives on your blocks, because it will stop the page from being cacheable. It's better to use customer sections to create user-specific data, because it will increase the response time, decrease the response times of your application. And never to put cacheable false directive to the default XML layout, because it will stop the whole page from being cached in full page cache. And this might actually break your site if you by mistake add a block that is cacheable false and make a deploy to production. When you have a peak, your application server might not be able to cope with the traffic. And use Varnish for full page cache instead of Redis or files, because it's much faster. And another thing I wanted to say is that you can use full page cache for caching GraphQL requests as well, which means if you create some headless applications or PWA, you can use Varnish as well to speed up the responses for example, for categories or for product pages. By default, only get and head requests are cached. But if you want to, you can modify the .vcl file for Varnish to make it not cache the GraphQL requests if they're so that you can send post requests to the GraphQL API and make them cacheable as well. It's possible. Do you have any questions?
Okay. I have expected something like Magento 1 Enterprise Edition or punching. Then you were able to put dynamically from the backend some section on the page that set to customers, because most of the customers don't like that delay on the IX, the page that you have the card saying quantity 0, then for example 5 items are loaded. How to prevent that delay?
Well, if your application is quick, the delay isn't that big, and you have to remember that the data stored in customer section is stored in this local storage of the browser. So if the data is updated only now and then, so when you have the data stored in local storage and you refresh the page, the AJAX request is not made, because the data is loaded directly from the browser cache. Okay, I cannot answer that. Sorry. Any other questions?
Do you recommend using any cache crawlers?
I think it's a
background process crawling a web page to cache every page.
It depends on your traffic, I suppose, and whether your pages change frequently. I think you can use a warmer to refresh the caches, for example, at night. If you have some cron updates at night, and you want those pages to be warmed up before your customers come in, you can do it. Sure, there are some solutions that can do that for you.
Do you maybe know some kind of module or something that would improve how flashing the full page cache works when you have, for example, multiple storages? Because you can end up in a situation where you have some products assigned to a store group from one domain, and also you have four separate domain with another set of products, and then you maybe don't want to flash all the full page cache for the full application. Is it possible to somehow divide it per domain?
There are modules that allow you to purge certain URLs that you just say which URL should be purged, and they are purged. So I think you could use such a module to purge this. It wouldn't be automatic. You would have to do some coding as well, but there are modules that can do that. Okay, I think we are out of time, so if you have any other questions, feel free to catch me somewhere here or at the after party, and thank you very much.